Welcome back to the channel. So today in this video we are going to attempt question number 4 and question number 5 of chapter Relations and Functions of class 11th exercise 2.2 CBSE mathematics. Question number 4 is the figure 2.7, that is this figure, shows a relationship between the sets P and Q. Write this relation. Part number first is in set builder form. Part number second is roster form. What is its domain and range? We already know what relations are. Take for example, we have set A having elements 1, 2 and 3 and we have set B with elements 2, 3 and 4. Now suppose we are given with a relation which is defined as x comma y such that y is equal to x plus 1. Here x belongs to set A, it is the input, and y belongs to set B and it is the output. So here relation will be, if we put value of x from set A, that is 1, we'll be having value of y as x plus 1, that is 2, which is there in set B. Similarly, if we'll put value of x as 2, we'll get value of y as 3. And if we'll put value of x as 3, we'll get value of y as 4. We cannot put the value of x as 4, as 4 is not there in set A. So here one can observe that the first element of each ordered pair is related to the second element of ordered pair by this very relation. Another thing we noted is that relation is a subset of set A cross B. That is the Cartesian product of two sets. We have also gone through domain, codomain, and range. Domain is the set of all first elements of ordered pairs. So in our example, domain will be having elements as 1, 2 and 3. Codomain is the whole set B. And range, it is the set of all second elements of ordered pairs. So in our example, range will be having elements as 2, 3 and 4. Keeping all these things in mind, let us attempt question number 4 and 5. So in question number 4, we'll have to represent the relationship which is given in figure 2.7 in the set builder form. So here one can observe that each element of Q can be obtained by subtracting 2 from each element of P. So here 5 minus 2 is 3. Similarly, 6 minus 2 is 4 and 7 minus 2 is 5. So if elements of P are our input, that is each element represents x, and elements of Q are our outputs, that is each element of Q represents y, then one can observe that y is equal to x minus 2. Therefore, in question number 4, part number first, the relation in set builder form can be represented as follows. X comma y such that y is equal to x minus 2, where x is equal to 5, 6 and 7. Part number second, we have to represent this very relation in roster form as well. So in roster form, this relation will be having elements as, the first element will be 5 comma 3, that is this element and this element. The second element will be 6 comma 4, that is this one and this one. And the last element will be 7 comma 5, that is this one and this one. Now what is the domain and range of this very relation? So here, domain of R, we know what domain is. It is the set of all first elements of a relation. So here in this case, the domain will be having elements as 5, 6 and 7. And what about range of relation R? It is the set of all second elements of the ordered pairs. So this set will be having elements as 3, 4 and 5. That is, domain of R is a set with elements 5, 6, 7 and range of R is a set with elements 3, 4, 5. Towards next question. Let set A contain elements 1, 2, 3, 4 and 6. Let R be a relation on A defined by A comma B such that both A and B belong to set A and B is exactly divisible by A. Part number first is write R in roster form. Part number second is find the domain of R. And part number third is find the range of R. So this is question number 5. Here we are given with a relation where A comma B such that both A and B they belong to set A and B is exactly divisible by A, which means that the second element should be exactly divisible by the first element. So in roster form, this relation will be having elements as the first element is 1 comma 1, the second will be 1 comma 2, as 1 is the factor of every number and itself as well. Similarly, the next element will be 1 comma 3, the next element or ordered pair will be 1 comma 4, and the next element will be 1 comma 6. Here each of the second element is divisible by the first element. The next element will be 2 comma 2, as every number is divisible by itself. The next element will be 2 comma 4, and the next one will be 2 comma 6. Similarly, we have 3 comma 3 and 3 comma 6. The next one will be 4 comma 4, and the last one will be 6 comma 6. So this is how this relation can be represented in roster form. Part number second, we need to find domain of R. Here again we know that domain, it is the set of all first elements of ordered pairs. So this set will be having elements as 1, 2, 3, 4 and 6. As repetition is not allowed, so each element will be written only once. Here one can observe that these are the elements of set A. So here domain of R is the set A itself. And in third part, we'll have to find range of relation R. It is the set of all second elements of ordered pairs of a relation. So this set will be having elements as 1, 2, 3, 4 and 6, which is again set A. So here again range of relation R is set A. Hope this makes sense. Do subscribe to the channel for more such content and thanks for watching.